today we have a topic suggested by Potato Bird. And basically it says to solve systems of equations. So today we have a systems of equations, y plus 2 over 8 equals x, and 2y equals 2x plus 10. So there are three ways to solve systems of equations. Today we're going to be going over two, graphically and substitution.
So first, let's go over how to solve systems of equations graphically. So you graph the equations, and then you find the points of intersection.
POI stands for point of intersection. So today we're just going to do that. Find the point of intersection. But before we can find the point of intersection, what we have to do is we have to make these equations easier to graph. So let's start with the first equation. First equation is y plus 2 over 8 equals x. Since fractions are messy to deal with, we'll multiply both sides by 8. Then subtracting 2 from y plus 2, we get y equals 8x minus 2. And that's the first equation. For the second equation, 2y equals 2x plus 10, what we can do actually is it's basically 2 times y equals 2 times x plus 5. Because both sides have the common factor of 2, we can cancel them out. And y just equals x plus 5. And now we can graph these equations using a graph. So as you can see here, you can use the y-intercepts by just using the constant term afterwards, and you can use the slope, which is the multiple times the constant times x. So here it's a slope of 8, rise over run equals 8. So as you can see, there's a clear intersection point right here. That intersection point, if we kind of along the lines, that is point 1 comma 6. And that's all for graphing. Basically, graphing is easy to do when you have a calculator or you have a lot of spare time and you just want to see the picture of the graphs. It's really useful with a calculator because doing this takes too long, pretty much. The other two ways are much faster than doing graphing. So now let's look at the second method of solving systems of equations, which is by substitution.
So basically what I was trying to explain here was that you want to solve an equation for y. Using that equation, which is in terms of x, you can substitute it into the other equation. This eliminates the y variable completely and allows you to solve for x. Then we get an x value which we can use to plug into a simple equation to get y. You can choose which equation to do this for, as you should get the same value of y for both.
Basically, this allows us to cancel out the variable y, but you can also do this with x. Let's say this example, you have x already solved for, you can plug that in here. Usually solving for y is much less complicated as you don't want to deal with this many fractions inside the systems of equations. Okay, so now let's solve the equations in terms of y. So at first thought, the first equation might look easier to deal with, but actually the second equation is easier because, as we said before, it's basically just 2 times y equals 2 times x plus 5. And the 2's cancel out, so it's just y equals x plus 5. Just a simple equation in terms of y. Then we have this other equation. Using this equation, y equals x plus 5, we can actually plug that into y. Since this is y, basically. And you get x plus 7 over 8 equals x. But that's just x plus 7 equals 8x. which is basically 7x equals 7, or x equals 1. And that's your answer for x. But we also want to find y, since our coordinate in the end is in terms of x and y. So y is x plus 5, as you see here. So x equals 1, we plug that in, and we get y equals 1 plus 5, or y equals 6. So now let's plug in our answers into the coordinate, and we get 1 comma 6, which is the same answer as before. It's the same problem, so you get the same answer, which is a good thing, because then you know the solution works. So substitution, in my opinion, is much faster than graphing, as graphing just takes too long to do, making all the things perfect. So whenever you want to use something, try substitution. Or you can use the example in my next video, which is right here, if it's out yet. And then next video we'll be covering elimination, which is even faster than this substitution. So that's all for today's video. Please like and subscribe, as it helps me out a lot. And please comment down below what other problems you would like me to solve in the future. That's all for today's video. Bye!